So hello together. Okay, it's a bit noisy. Yeah, okay. Thank you. Yeah. So my name is Torsten Krone. I'm proud to present you today our robust sensor solutions from our company, the Insenso GmbH. So I'm the product manager and I'm in the field of pressure sense dies for more than 15 years. And we all know that there are some specific requirements depending on the different applications. And today I would like to present to you like a new product platform, but also some solutions for common pressure sense problems. So maybe a few words to our company. The Insenso GmbH had been founded 2020, so we are a relatively young company. We are located in Berlin, but even if the company is relatively young, unfortunately, I'm not so young anymore. So me and my colleagues, we are all like in this business for more than 15, 20, even 30 years. So we are actually focusing on the development of pressure sensor solutions, and we are actually starting really at the start point. So we design our own mask to be capable to adjust to any kind of problems the customer needs, the customer requires. So besides the pressure sense dies, we can even do like further integration, so we can realize modules, sensors, and even complete systems, together with our partner company located in China. So here you will see like a very nice overview of our portfolio and the capabilities that we can actually offer. As I mentioned, we are actually starting here really in the beginning, where we can do our own designs with our core IP, so with the MEMS processes, which are like all in our house. And we have specific technologies to achieve very high accuracy and high long-term stability. And as mentioned, we are already in this business for quite some time, so we are familiar with the needs of our customers. So sense dies are actually more focused for customers which are actually processing or like producing their own sensors in a huge quantity. But we are also aware that we are certain customers which are more focusing on the higher end, which have maybe a very high expertise in their own applications and do like specific adaptations for the needs of the customer. And maybe they do not have a very high quantity of sensors they require. So that's why we also offer like pre-assembled solutions, like a first packaging. Because as a pressure sensor is mainly just measuring the mechanical stress, also the packaging has a very high influence to the sensor performance. So here we can offer like standard solutions, and together with our customers, we can also provide second level packaging, like integrate the PCB, like in calibration, or even like a complete system with customized labeling or whatever the customer requires. Here's just a very general working principle of how a pressure sense die or like a piezoresistive pressure sensor is working. So we have like on the left hand side, like the top view of a sensor. Here would be a cross section, and we have like piezo resistors located at the edge of the membrane. And we have 4 of them which are combined together in a wheatstone bridge. So if a pressure is applied from the front side, the membrane will be deflected and you will have some mechanical stress introduced in the piezo resistors, which will then lead to a change of resistivity due to the piezoresistive effect, which is then producing the output signal that we need to measure any kind of pressure. So the piezoresistive sensors have one big drawback. It's actually the high temperature dependency of the output signal, which always need to be compensated. So here we have like one diagram showing the output signal. It's normalized to 25 degrees C of the IPD40 at a 5-volt supply. You can see that the output signal is dropping by almost 20% from 25 to 125 degrees C. But this is just the fact at 5-volt supply. So if you switch from constant voltage supply to a constant current supply, suddenly the output signal will be completely different. So here we have a different factor which coming to place. It's actually the change of the bridge resistance. as we have the TCR, like the temperature coefficient of the bridge resistance, the resistivity of each single resistor will change, like increase with temperature, and so the voltage drop at each resistor. So in the end, we have some kind of overcompensation of the output signal, and the signal is actually increasing over temperature. So with the new product that we just developed, we try to optimize these by adjusting the front-end process and the processes to have a slightly lower temperature dependency on voltage supply, and the big benefit would be actually at current supply. So as now the temperature coefficient of the bridge resistance, like the change of resistivity over temperature, is more adjusted to the sensitivity drop over temperature, the output signal is very linear and the failure is much smaller. So of course I understand the most customers of us are using like ASICs or microcontroller, so they have lookup tables, they have a polynomial fit. So of course they can also calibrate like nonlinearity like this, like on the IPD40. But a more linear or less temperature dependency will also have the big benefit that the variation is smaller, so you could reduce the calibration points and still get a very good output signal, or there's still a lot of application which require an analog compensation due to the requirement to get like a higher update rate. So an ASIC will just give you maybe 10 kilohertz, and with this, with such kind of passive compensation, you get like a direct feedback. So, but anyway, also for ASIC compensated or microcontroller compensated sensors, this new technology or this new product family will give you a big benefit on long-term stability. So one point what we do within our production is we call it like the stability test. So to control the quality of our products, each production lot will undergo such kind of test. So here we will run such kind of profile. So we will run at 25 degrees C for around 4 to 6 hours, then increase the temperature to 125 degrees C and keep it for at least 24 hours, and then come back to 25. So in the end, from this profile, actually two parts are very interesting for us. The one is actually the behavior of the sense die during 125 degrees C. So of course we always need to wait until the complete system is more or less temperature stabilized, and then we measure the output signal over time. And what we want to see is of course like a really nice line, so which is like running to a defined value, and of course this kind of drift has to be very small. And here in comparison, the IPD42, which also has a good result, compared to the IPD80, you see that the signal noise is much better and the output signal of the IPD80 is pretty nice. So this will give like, especially for applications which has a demand for a high long-term stability, a big benefit. Besides this, of course, also the repetitivity of the output signal at 25 degrees C is important. So like, does the signal is coming back after 125 degrees C? So also here we see that the quality of the sensor is pretty nice. So, but besides this, we can also offer solution for some more specific application requirements. For example, like a vacuum gauge sensor. Most of our customers actually using our dies, they put it in such kind of oil-filled module. So you will have like the die attached on an adhesive. This complete sensor is then oil-filled, so it's encapsulated and can be used in different medias. So, but in case that you will run into the situation that you want to even have like a capability to have like a vacuum from the front side or like an under pressure, you have run into the situation that a soft glue will not be usable here because the air from the backside would be permeate like the adhesion layer, and you will actually end up with air sucked through this adhesive layer into your oil filling, which will then damage your, or like the sensor energy, and the calibration is gone and the behavior will change, and in the end you cannot use it anymore. So the alternative that you could use here is actually switch from using a soft glue by using a hard glue. But as I mentioned before, the pressure sense die is actually measuring the mechanical stress. So if you no longer use a soft glue but use a hard glue, you will have a lot of mechanical stress introduced by the packaging, which then will be measured by the sense die again. So here the alternatives that we could offer is like using, instead of a thin glass layer, a 2mm glass body, which will then make like a bigger distance or like a stress relief from the actual packaging to the sensing element on the top side. Yeah, with this kind of diagram, I try to show that the mechanical stress itself has like different effects. So the packaging, of course, the influence is dropping with the distance or like with the thickness of the glass, but at the same time, also the glass influence. So if you make it even bigger, there would be always a disadvantage. So which means like actually for different kind of packaging solutions, like what kind of material you are using, you always need to find like a sweet spot of the optimized like adhesive and materials you are using. So besides this, we also offer something special. I mean, from our point of view, it's something special. It's a differential pressure sensor. Maybe just as a very quick summary, so we always separate between like an absolute pressure sensor, which has like an encapsulated cavity on the backside of the cavity. So there's typically like a vacuum or technical vacuum in the inside. So you can always measure pressure from the front side with a reference to the backside. The relative sensor would have like a hole inside, so quite simple. And then you could measure always pressure from the front side relative to the outer world, the atmosphere or whatever. The differential pressure is actually quite similar to relative, but here the difference is actually that you want to measure like very small pressure differences, but maybe even at a very high common mode pressure. So for example, if you want to measure 100 millibar at 200 bar from both sides. So here you would have the effect that as the material is not exactly the same, the properties of glass and silicon are different. So glass, the E modulus of glass is a bit higher, so it's a bit weaker. So at a high pressure, the sensor itself would start bending by itself and then would cause again a mechanical stress, which then would be measured by the sensor. So you could compensate this by using an additional absolute pressure sensor, or what we would offer is like a combination of a silicon and a silicon wafer. So this is of course a bit more tricky because anodic bonding is, I would say, relatively easy, and silicon direct bonding is actually, because the surfaces has to be very clean, and actually there are not a lot of companies which will offer this on an industrial grade. So here the big advantage would be the combination of same material properties, which will then lead to high-end products. So I just like to wrap up that with our products and especially with our capabilities that we would offer, like actually starting from the pressure sense die across the complete manufacturing chain, we could offer various kind of products. And we have like standard solutions on different levels. So if a customer is approaching us and requires a specific solution, we can make adjustments like on the module stage, or maybe like even like on the sensing stage by adjusting certain parameters like sensitivity or temperature properties. Of course, changing properties on pressure on the sense die stage would require a change in the semiconductor process. which is just possible on higher volume, I would say. And nevertheless, we can also offer like different solutions. For example, instead of a standard steel membrane, we can realize flush membranes. For example, if you have like in the food industry, it has to be like a front surface which can be easily cleaned, or like using specific oil filling to be conformed to the food and water industries. Yeah. Thank you very much. That's actually it. And if you have any further questions, you can approach me. Or of course, we would be happy if you would just pass by and visit us at our booth at 316. Thank you.